Hello, my dear students. Welcome to Teacher at Home. Today class we are going to learn the second chapter. Is matter around us pure? How do we judge whether milk, ghee, butter, salt, spices, mineral water or juice that we buy from the market is pure? ശുദ്ധമാണെന്ന് എങ്ങനെ മനസ്സിലാക്കാം? Have you ever noticed the word pure written on the backs of the consumables? For a common person, pure means no adulteration. But for a scientist, all these things are actually mixtures of different substances and hence not pure. For example, milk is actually a mixture of water, fat, proteins, etc. When a scientist says that something is pure, it means that all the constituent particles of the substance and are the same in their chemical nature. A pure substance consisted of a single type of a particle. In other words, a substance is pure, single form of matter. As we look around, we can see that most of the matter around us exists as mixtures of two or more pure substances. For example, seawater, minerals, soil, etc. are all mixtures. What is a mixture? Mixture are constituted by more than one kind of pure form of matter. We know that dissolved sodium chloride can be separated from water by the physical process of evaporation. However, sodium chloride is itself a pure substance and cannot be separated by physical process into chemical constituents. Similarly, sugar is a substance which contains only one kind of pure matter and its composition is the same throughout. Soft drinks and soil are not single pure substances. Whenever the source of a pure substance may be, it will always have the same characteristic properties. Therefore, we can say that a mixture contains more than one pure substance. Type of mixtures. Depending upon the nature of components that form a mixture, we can have different type of mixtures. Let us divide the class into group A, B, C and D. Group A takes a beaker containing 50 ml of water and one spatula full of copper sulfate powder. Group B takes 50 ml of water, 2 spatula full of copper sulfate powder in a beaker. Group C and D can take different amount of copper sulfate and potassium permanganate or common salt, sodium chloride and mix the given components to form a mixture. Report the observations on the uniformity in color and texture. Groups A and B have obtained a mixture which has a uniform composition throughout. Such mixtures are called homogeneous mixture or solutions. Some other examples of such mixtures are salt dissolved in water, sugar dissolved in water. Compare the groups, color of the solutions of the two groups. Though both the groups have obtained copper sulfate solution, but the intensity of color of the solution is different. This mixture shows that a homogeneous mixture can have a variable composition. Group C and D have obtained mixtures which contain physically distant parts and have non-uniform composition. Such mixtures are called heterogeneous mixtures. Mixtures of sodium chloride and iron fillings, salt and sulfur, and oil and water are examples of heterogeneous mixture. Let us divide the class into 4 groups A, B, C and D. Distribute the following samples of each group. Few crystals of copper sulfate to group A, 1 spatula full of copper sulfate to group B, chalk powder or wheat flour to group C, few drops of milk or ink to group D. Each group should add the given sample in water and still properly using a glass rod. Are the particles in the mixture visible? Direct a beam of light from a torch through the beaker containing the mixture and observe from the front. Was the path of the beam of light visible? Leave the mixture undisturbed for a few minutes and set up the filtration apparatus in the meantime. Is the mixture stable or do the particles begin to settle after some time? Filter the mixture if there are any residue on the filter paper. Discuss the results and form the opinion. Group A and B have got a solution. Group C has got a suspension and Group D has got a colloidal solution. So now we shall learn about some solution, suspension and colloidal solution in the following sections. What is a solution? A solution is a homogeneous mixture of two or more substances. You come across various types of solution in your daily life. Lem- Lemonade, soda water, etc. are examples of solutions. Usually, we think of a solution of a liquid that contains either a solid, liquid, or a gas dissolved in it. But we can also have solid solutions, gaseous solutions. In a solution, there is homogeneity at the particle level. For example, lemonade tastes the same throughout. This shows the particles of sugar or salt are evenly distributed in the solution. Alloys. Alloys are mixtures of two or more metals or a metal and a non-metal. Cannot be separated into their components by physical method. But still, an alloy is considered as a mixture because it shows the properties of the constituents and can have variable composition. For example, brass is a mixture of approximately 30% zinc and 70% copper. A solution has a solvent and a solute as its components. The component of a solution that dissolves the other component in it. Usually the component present in a larger amount is called a solvent. Component of a solution dissolved in the solvent is called the solute. A solution of sugar in water is a solid in liquid solution. In this solution, sugar is the solute and water is the solvent. A solution of iodine in alcohol known as tincture of iodine has iodine solid as a solute and alcohol liquid as a solvent. Aerated drinks like soda water, etc. are gas in liquid solutions. These contain carbon dioxide gas as solute and water as liquid as solvent. Air is a mixture of gas in air. Air is a homogeneous mixture of a number of gases. Its two main constituents are oxygen 21% and nitrogen 78%. Other gases are present in very small quantities. Properties of a solution. A solution is a homogeneous mixture. The particles of a solution are smaller than 1 nanometer, 10 to the power minus 9 meter in diameter. So they cannot be seen by naked eyes. Because of very small particle size, they do not scatter a beam of light passing through the solution. So the path of the light is not visible in a solution. Solute particle cannot be separated from the mixture by the process of filtration. The solute particles do not settle down when left undisturbed, that is, a solution is stable. Concentration of a solution. In activity 2.2, we observe that groups A and B obtain different shades of a solution. So we understand that in a solution, the relative proportion of a solute and solvent can be varied. Depending upon the amount of solute present in a solution, it can be called dilute, concentrated or saturated solution. Dilute and concentrated are comparative terms. In activity 2.2, the solution obtained by group A is dilute as compared to that obtained in group B. Take approximately 50 ml of water, each in two separate beakers. Add salt to one beaker and sugar or barium chloride in the second beaker with continuous stirring. When no more solute can be dissolved, heat the contents of the beaker to raise the temperature by about 5 degrees Celsius. Start adding the solute again. Is the amount of salt and sugar or barium chloride that can be dissolved in water at a given temperature the same? At any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be a saturated solution. In other words, when no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution. Amount of the solute present in the saturated solution at this temperature is called its solubility. If the amount of solute contained in a solution is less than that of the saturated level, it is called as unsaturated solution. What would happen if you were to take a saturated solution at a certain temperature and cool it slowly? We can infer from the above activity that different substances in a given solvent have different solubilities at the same temperature. Concentration of a solution is the amount of solute present in a given amount of solution. There are various ways of expressing the concentration of a solution, but here we will learn about three methods: mass by mass percentage of a solution, mass of a solute by mass of a solution into 100. Mass by volume percentage of a solution, Mass of a solute by volume of a solution into 100. Volume by volume percentage of a solution. Volume of a solute by volume of solution into 100. For example, a solution contains 40 gram of common salt in 320 gram of water. Calculate the concentration in terms of mass by mass percentage of a solution. Mass of a solute 40 gram. Mass of solvent 320 gram. That is already given. We know mass of a solution formula is mass of solute plus mass of solvent. It is 40 plus 320 is 360 gram. Mass percentage means mass of solute by mass of solution into 100. Mass of solute is 40 by solution 360 into 100, 11.1 percentage. What is a suspension? Non-homogeneous systems like those obtained by group C in which solids are dispersed in liquids are called suspensions. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Particles of a suspension are visible in the naked eye. Properties of a suspension. Suspension is a heterogeneous mixture. Particles of a suspension can be seen by the naked eye. Particles of a suspension scatter a beam of light passing through it and make its path visible. Solute particles settle down when a suspension is left undisturbed. That is, a suspension is unstable. They can be separated from the mixture by the process of filtration. When the particles settle down, the suspension breaks and does not scatter light anymore. What is a colloidal solution? The mixture obtained by group D in activity 2.2, it is called a colloid or a colloidal solution. Particles of a colloid are uniformly spread throughout the solution. Due to the relatively smaller size of the particles as compared to that of a suspension, the mixture appears to be homogeneous. But actually, a colloidal solution is a heterogeneous mixture, for example, milk. Because of the small size of colloidal particles, we cannot see them with the naked eyes. But these particles can easily scatter a beam of light as observed. The scattering of a beam of light is called Tyndall effect after the name of the scientist who discovered the effect. Tyndall effect can be observed when a fine beam of light enters a room through a small hole. This happens due to the scattering of light by the particles of dust and smoke in the air. Tyndall effect can be observed when sunlight passes through the canopy of a dense forest. In the forest, the mist contains tiny droplets of water which act as particles of the colloids dispersed in air. Properties of a colloid. A colloid is a heterogeneous mixture. The size of the particles is too small to be individually seen with the naked eyes. Colloids are big enough to scatter a beam of light passing through it and make its path visible. They do not settle down when left undisturbed, that is, a colloid is quite stable. They cannot be separated from the mixture by the process of filtration. But a special technique of separation is known as the centrifugation, can be used to separate the colloidal particles. Component of a colloidal solution are the dispersed phase and the dispersion medium. Solute-like component of the dispersed particle in a colloid form the dispersed phase, and the component in which the dispersed phase suspended is known as the dispersion medium. Colloids are classified according to the state, solid, liquid and gas of the dispersing medium and the dispersed phase. Few examples are given. Dispersed phase liquid, dispersion medium gas, type aerosol, example fog, cloud, mist. Solid, gas, aerosol, smoke, automobile exhaust. Gas, liquid form, shaving cream. Liquid emulsion, milk face cream. Solid liquid salt, milk of magnesia mud. Gas solid form rubber sponge, pumice. Liquid solid gel, jelly cheese butter. Solid salt, colored gemstone and milky glass. Physical and chemical changes. In the previous chapter, we have learned about a few physical properties of matter. Property that can be observed and specified like color, hardness, rigidity, fluidity, density, melting point, boiling point are the physical properties. Interconversion of states is a physical change because these changes occur without a change in the composition and no change in the chemical nature of the substance. Although ice, water and water vapor all look different and display different physical properties, they are chemically the same. Both water and cooking oil are liquid. but their chemical characteristics are different. They differ in order and inflammability. We know that oil burns in air, whereas water extinguishes fire. It is a chemical property of oil that make it different from water. Burning is a chemical change. During the process of one substance react with another to undergo a chemical change in chemical composition. Chemical change brings change in the chemical properties of matter and we get new substances. A chemical change is also called a chemical reaction. During burning of candle, both physical and chemical change take place. What are the type of pure substances? On the basis of chemical composition, substances can be classified either as elements or compounds. Elements. Robert Boyle was the first scientist to use the term element in 1661. Antonio Lavoisier, a French chemist, was the first to establish an experimentally useful definition of an element. He defined an element as a basic form of matter that cannot be broken down into simpler substances by chemical reaction. Element can be normally divided into metal, non-metal, and metalloids. Metals usually show some or all the other following properties. They have a luster, shiny appearance. They have a silvery gray or gold yellow color. They conduct heat and electricity. They are ductile. They are malleable. They are sonorous, making a ringing sound when heat. Example of metals are gold, silver, copper, iron, sodium, potassium, etc. Mercury is the only metal that is liquid at room temperature. Non-metal usually show some or all other properties. They display a variety of colors. They are poor conductor of heat and electricity. They are non-lustrous, sonorous, or malleable. Example of non-metals are hydrogen, oxygen, iodine, carbon, bromine, chlorine, etc. Some elements have intermediate properties between those of metals and non-metals. They are called metalloids. Example are boron, silicon, germanium, etc. The number of elements known at present are more than 100. 92 elements are naturally occurring and the rest are man-made. Majority of the elements are solid. 11 elements are in gaseous state at room temperature. 2 elements are liquid at room temperature, mercury and bromine. Elements gallium and cesium become liquid at the temperature slightly above the room temperature 303 Kelvin. Compound. A compound is a substance composed of 2 or more elements chemically combined with one another in a fixed proportion. Divide the class into two groups. Given 5 gram of iron fillings, 3 gram of sulfur powder in a china dish to both the groups. Group 1. Mix and crush iron fillings and sulfur powder. Group 2. Mix and crush iron fillings and sulfur powder. Heat this mixture strongly till red hot. Remove from flame and let the mixture cool. Group 1 and 2. Check for magnetism in the material obtained. Bring a magnet near the material and check if the material is attracted towards the magnet. Compare the texture and color of the material obtained by the groups. Add carbon disulfide to one part of the material obtained. Still well and filter. Add dilute sulfuric acid and dilute hydrochloric acid to the other part of the material obtained. Perform the above step with two elements. Did the material obtained by the two groups look the same? The gas obtained by group 1 is hydrogen. It is colorless, odorless and combustible. It is not advised to do the combustion test for hydrogen in the class. The gas obtained by group 2 is hydrogen sulfide. It is a colorless gas with the smell of rotten eggs. You must have observed that the product obtained by both the groups show different properties, though the starting materials were the same. Group 1 has carried out the activity involving a physical change, whereas the case of group 2, a chemical change. Material obtained by group 1 is a mixture of two substances. The substance given are the elements iron and sulfur. The properties of the mixture are the same as that in constituents. Mixture. Elements are compound just mixed together to form a mixture and no new element is formed. Elements react to form new compounds. A mixture has a variable composition. The composition of each new substance is always fixed. A mixture shows the properties of constituent substances. The new substance has totally different properties. The constituent can be separated fairly easily by physical method. Constituent can be separated only by chemical or electrochemical reactions. Material obtained by group 2 is a compound. On heating the two elements strongly, we get a compound which has totally different properties compared to the combining elements. The composition of a compound is the same throughout. You can also observe from the texture and the color of the compound same throughout. Thus, we can summarize the physical and chemical nature of matter in the following graphical organizer. Matter, solid, liquid and gas, pure substance, mixture. Pure substance, element and compound. Cannot be broken down into simpler substances. Example, copper, iron, hydrogen and mercury. Compound have a fixed composition, can be broken down into chemicals, elements by chemical and electrochemical reactions. For example, water, methane, sugar and salt. Heterogeneous, uniform composition, non-uniform, homogeneous, uniform, heterogeneous, non-uniform composition. For example, sugar in water, salt in water, sulfur in carbon disulfide, water in alcohol. Heterogeneous, sand and salt, sugar and salt, water in oil. That's all about this chapter. If you are interested, please do like, share and subscribe my channel. Okay, thank you.